PU2 champions, welcome to day 8 of 21 days challenge to get 95% in your second PUC board exam. So as part of today's challenge, I have given you 2 chapters for homework, amines from chemistry and relations and functions from maths. So you have to revise these 2 chapters and practice its most important questions from the PDF I have provided. If you haven't downloaded yet, the link is there in the description section. So please click on the link, visit the page and download the most important questions PDF and do practice these questions. And in this video, we are going to do the one shot quick revision of the chapter amines. Okay, this is a very small chapter, highly important and highly scoring chapter. Okay, let's get started and first see what we have in today's class. So first of all, we'll talk about the structure of amines, its classification, nomenclature, preparation of amines, physical properties, chemical reactions, Diazonium salts, its preparation, physical properties, chemical reactions and some uses. Okay, so let's see the structure of amines now. First of all, if you see, amines are the derivative of ammonia. So what is the hybridization of nitrogen in ammonia? It is sp3 hybridized. Okay, so sp3 hybridized means there are 4 hybrid orbitals. Okay, and each of these hybrid orbital is sp3 hybridized. Now what happens in nitrogen? If you see, there are 4 hybrid orbitals like this. Okay, I'll show you the structure as well. So each of these hybrid orbital, out of that 3 will form bond with hydrogen. Okay, and one of this hybrid orbital contains a lone pair of electrons which is there for its bonding, and like one of the hybrid orbitals contains the lone pair and the other 3 hybrid orbitals form bond with hydrogen. Clear? Next, what is the shape of this geometry? So it is an electron geometry, tetrahedral structure here. The molecular shape, if you see, because we have a lone pair of electrons here, so it is a pyramidal shape and the lone pair occupies one position. And the bond angle here is actually the tetrahedral angle is 109.5 degree, normal tetrahedral, but since this is pyramidal, here due to repulsion, the angle is slightly less than 109.5 degree. Examples, in trimethylene bond angle, in trimethylene, the structure, the bond angle is 108 degree. Okay, now what is the reason for? You can see that there is lone pair and this is bond pair, right? Okay, lone pair, bond pair, repulsion is there. Due to this, these bonds come closer to each other and the bond angle between them actually decreases. Okay, so now I'll show you the structure of this one. So you can see that this is how the ammonia structure looks, or the derivative of ammonia. You can see here ammonia is there, H is there, and this is a square pyramidal structure. And what happens here is, if any of this hydrogen is replaced with the R group, then we get amines. Okay, now we will see the classification of amines as primary, secondary and tertiary amines. So as I say, in this nitrogen, in this ammonia there are 3 hydrogens, right? So if one of the hydrogen is replaced with R group, then it is a primary amine. If 2 hydrogens are replaced with R group, then it is a secondary amine, and 3H is replaced with R group, then it is a tertiary amine. Now let's talk about what is a simple and mixed amine. Okay, so amines are said to be simple when all the R groups or the alkyl or the aryl groups are same. And if this aryl group or alkyl groups are different, then we call it as a mixed amine. So my dear children, here's something, a very big announcement for all of you. So KCET 2026 is just hardly 75 days away. And at this point of time, it is very important that you not only study for this exam, but also you practice thoroughly. So to help you with this, I have launched the KCET 2026 test series named as Fighter KCET test series, which will help you to train like a fighter for KCET. And here you will be getting questions that are designed by KCET experts based on the KCET exam pattern and syllabus. You will have total 18 full-length tests, 6 each from physics, chemistry and maths. You will have detailed solutions, test analysis reports, and of course for chemistry you will get the video solutions as well. So my dear children, please remember the link for this test series is there in the description section, and this whole test series is available at a very affordable price of just rupees 399. Okay, and this price is for now. Obviously after some time it will be increasing, so please purchase it right now if you want to prepare for KCET in the right way with the right set of test series. Okay, so now moving ahead to nomenclature, you can check here that nomenclature is done in this way: CH3, CH2, NH2, suppose it is there. This is a primary amine, right? So the name will be ethyl amine or ethanamine. Next, if I have a structure like this is propyl amine or propanamine. Now here we have NH2, CH3, CH, CH2. So this is isopropyl amine or propane 2 amine. Now here we have N-methyl ethyl amine, or I can say N-methyl ethanamine. Then we have N-dimethyl methanamine. Then you have N-ethyl, N-ethyl, and here you have butane 1 amine. Next you have here 1, 2, 3. So propene, prop 2 en 1 amine. Then you have 2 amines here. So hexane 1,6 diamine. Okay. Now we'll talk about NH2. Here it is aniline, NH2 and CH3. This is 2 methyl aniline, NH2Br. This is 4 bromo aniline. Next we have N and then 2 CH3 group is there. So you have NN dimethyl benzene structure or benzenamide, sorry. Now we'll talk about the preparation of amines here. So amines can be prepared in different ways. So the first method is from reduction of nitro compounds. Then we have ammonolysis of alkyl halides, reduction of nitriles, reduction of amides, and Gabriel phthalimide synthesis. So let's first start with the reduction of nitro compounds, and lastly we have Hoffman bromamide degradation as well. So if I talk about reduction of nitro compounds, so let's see this one. The first one is this one, okay. Reduction of nitro compounds, you can use SnHCl, FeHCl or hydrogen palladium with ethanol, okay. So that will give you RNH2. The second method is your ammonolysis, where you have NH3 and RX. So here what happens, one H from here and one X goes out. So you can basically think that this X is replaced with NH2 group. So you first of all, NH3 has a lone pair of electrons, so it acts on this R group because R is electropositive, X is delta minus. So you get a salt like this, and then when you treat it with NaOH, you get RNH2. Okay, that is the second method. And once you get this RNH2, if you treat it with more Rx, then again one of the hydrogen is replaced with R, you get R2NH. After that, again if you treat it with Rx, one more hydrogen is replaced with R group, so you get R3N. Then if you again treat it with Rx, one more group is added here, so we'll get R4N plus and X minus. Okay, that is what is ammonolysis, second method. The third method is reduction of cyanides. Okay, if you see, we have seen reduction of nitriles. So if you treat this nitriles with H2 nickel or LiAlH4 or NaC2H5OH, okay, hydrogen nickel or lithium aluminium hydride or sodium ethanol, then you will get RNH2. Next, fourth one is RCONH2. This amide group is there. If you treat it with lithium aluminium hydride, it gets converted to RCH2NH2. Okay, so if you have RCONH2 with lithium aluminium hydride, that gives you RCH2NH2. Next, fifth one is here Hoffman bromamide degradation. If you see here bromine, so here what happens when you treat it with RCONH2, this particular CO group is actually removed and we get RNH2. So you get products with products with one carbon less than the original reactant. So if I give you an example, suppose I have CH3, CH2 and then I have CONH2. Okay, suppose this is propanamide. Now if you treat it with lithium aluminium hydride, and if you treat it with one more reagent, that is your bromine and NaOH. Okay, so if you treat it with lithium aluminium hydride, what will happen? This group gets converted to CH2. So you have CH3, CH2, CH2, NH2. Okay, and then if you have bromine NaOH, what will happen? This whole part will vanish and you will get a product like this, CH3, CH2, NH2. Clear? Now we'll talk about Gabriel phthalimide synthesis, the last method. So here what we have phthalimide like this. Okay, then you treat it with KOH. So this H goes, you get N minus and K plus. You treat it with RX, so you get NR here. After that, you hydrolyze it with NaOH. So what will happen? This bond will break. You get COO minus and COO minus. And here RNH2 is formed and this is primary amine. Now we'll talk about the physical properties of amines. So physical state in order, first of all, lower aliphatic amines are gases. They have a fishy smell. You have to remember this, it can be asked in MCQ. Primary amines with 3 or more carbons are generally liquid because of mass increases, the intermolecular forces increases, and higher aliphatic amines are solids. Now color of aryl amines, if I talk about, anilines and other amines are usually colorless, okay. They become colored on storage due to the oxidation. Next, if we talk about the solubility of amines in water, lower aliphatic amines are soluble in water. The reason being they can form strong hydrogen bonding, and as the molecular mass increases, the R group increases, the solubility decreases. Again, increase in the hydrophobic part. If the hydrophobic part is more, then the hydrogen bonding is less. Okay. Now we'll talk some more comparison of solubility if you take amines versus alcohols. If we compare, so you can see that electronegativity of nitrogen is 3.0, whereas that of oxygen is 3.5, right? So alcohols are more polar. if alcohols are more polar, they form stronger hydrogen bonds than amines. So alcohols are more soluble than amines. So for example, there's a question, butane 1-OL versus butane 1-amine, which is more soluble in water? Obviously, since the oxygen is more electronegative, stronger hydrogen bonding is there in butane 1-OL, so that is why it is more soluble. Next, amines are also soluble in organic solvents like alcohol, ether, benzene, etc. Next is intermolecular hydrogen bonding in amines. If you check, okay, primary amines has two hydrogens, so they show maximum intermolecular hydrogen bonding. Then secondary amines show the weaker hydrogen bonding than primary amines, and tertiary amines do not show hydrogen bonding at all, so because they do not have any hydrogen attached to them. So that is why what happens, the boiling point is affected here. Primary amines have more boiling point, then secondary amines, and then tertiary amines. Now we will talk about the chemical reactions of amines. The first one is about their basic nature. Second one is about their alkylation. Third is acylation. Carbyl amine reaction, reaction with nitric acid, reaction with benzene sulfonyl chloride, and electrophilic substitution reaction. We have nitration and sulfonation and halogenation. Okay. Next, first let's talk about the gaseous phase. So if you see, when you have NR group, okay, so what will happen, these R group can donate electrons. Okay, now when these R groups donate electrons, the electron density on the nitrogen increases. Now if the electron density on the nitrogen increases, it can easily donate the electrons. On the basis of that concept, tertiary amines will have 3 R groups, so their basicity is highest. Now please remember, this is in the gaseous phase. Then we have secondary amine, and then we have primary amine. Now in aqueous phase, what happens, there are three other factors which also affects the basicity. Now in aqueous phase, what happens, once the substance is dissolved in water, the nitrogen lone pair easily forms bond with the water. Okay, there is hydrogen bond formed here, and these amines are now, I can say, hydrated. So what happens, the smaller the molecule, more hydration takes place, and it is more stable. So on the basis of that, primary is more, I can say, basic, then secondary, and then tertiary. It is the stability of the conjugate acid. Means what happens, when nitrogen takes this H plus, whatever the product is formed, that is the conjugate acid. Now because primary amines are small, they are more stabilized. So based on, I can say, solvation effect, okay, the order is this one. But in the aqueous phase, this particular reason that 3 R groups will donate more electrons, electron density will increase, so that effect is also there. Okay, so we have two major effects, and that is your inductive effect, I can say. Apart from that, there is steric effect as well. Okay, so based on these all effects, the order of basicity in aqueous phase is different. So here you can see it is 2 degree, 3 degree, 1 degree, and ammonia if it is a ethyl group. Okay, and this one is 2 degree, 1 degree, and 3 degree, and ammonia if it is a methyl group. Okay, 2 3 1 and 2 1 3. Now coming to aryl amines versus ammonia, aryl amines are less basic than ammonia. Okay, so if you see, you have NH2 group. Okay, now this NH2 group, lone pair of electrons are already in resonance. So what will happen, these lone pairs of electrons are not available for donation, they are involved in resonance. So because they are involved in resonance, they are not available. So what will happen, donation will not take place, and that is the reason the basicity of aryl amines is less. Okay, now we'll talk about the chemical reaction. So if you see, I'll show you the first basic nature we have discussed. Now we will talk about alkylation and acylation. So if you see, if you normally treat the first reaction, I'll take as second here, this is alkylation. So alkylation, what is happening here? When you take RNH2 and treat it with RX, so what will happen? One HX will go and hydrogen will be replaced with R group. So you will get R2NH. Okay. Next particular reason or next particular reaction is acylation. So for acylation, you can treat it with acid chlorides or acid anhydrides. And if you treat it with benzoyl chloride, then it is benzoylation. So we have this acylation. RNHCOR you get, then you have RNHCOR you get, RNHCOC6H5 you get. So these are all the examples of acylation reaction. Now next reaction is your fourth one, that is, I can say here, that is carbyl amine reaction. So this is our carbyl amine reaction. So here when you take primary amine and it is treated with chloroform and KOH, CHCl3 and KOH, you get RNC. Okay, now we will talk about the fifth reaction. You can see reaction with nitric acid. Okay, So you can see that if this is RNH2 is a aliphatic one. Okay, if it is aliphatic, then with nitric acid or nitrous acid you get alcohol. But if this RNH2 is a aromatic, means you can say aniline. Okay, if it is aniline, then with nitrous acid you get benzene diazonium chloride. Okay, benzene diazonium chloride. Clear? Now next reaction we have is reaction with aryl sulfonyl chloride. So this is the sixth reaction. So this particular benzene sulfonyl chloride is called as our Hinsberg reagent. Okay, now what is this Hinsberg reagent? So when you treat this one with primary amines, this HCl is removed and you get a structure like this. Now this particular structure has this acidic hydrogen, because of which it is soluble in alkali. Okay, salt is formed which is soluble in alkali. Okay, next we have again you have the secondary amine. Here also HCl is removed, you get a compound like this. Here there is no hydrogen attached, so salt is formed, but this salt is insoluble in alkali. Okay, now if you see benzene sulfonyl chloride with a tertiary amine and you react with this one, there is no reaction because here there is no hydrogen. Okay, so that is how we can separate primary, secondary and tertiary amines. Primary amines will form a salt, and then it is because this salt is having one acidic hydrogen, it will dissolve in alkali. Now secondary amines will form a salt because it doesn't have any acidic hydrogen, it is insoluble in alkali. Now next is tertiary amine. When it reacts, it doesn't form any product. So that is how we can differentiate. And the last reaction for amines is your electrophilic substitution. So if you see, we have aniline here, okay, and here some important reactions are obviously there. If you treat it with bromine water, you get 2,4,6 tribromoaniline. Okay, this is NH2, 2,4,6 tribromoaniline. Now if you treat it with concentrated HNO3 and H2SO4, so what we get here, we get all the three products. Like actually aniline is what? Aniline is a ortho para directing group, right? It is a electron donating group. So the NO2 group should come at the ortho and para position, but here we find a significant amount of meta product as well. Now the reason for meta product, this is NH2, okay, please take care. The reason for meta product is what? This, in this highly acidic medium, it is a base, right? It gets protonated, and once it gets protonated, it is like now a behaving as an electron withdrawing group. Okay, so meta position is also forms a major product. Next, if you treat it with sulfuric acid, you get a salt like this, and then you get a product which is the sulfonilic acid. Next, we have here some important reaction that, see, if I just do bromination, I am getting 2,4,6 tribromoaniline at the same time. If you just want ortho and parabromine separate products, so first of all you need to deactivate this NH2 group, and for that we acetylate it, okay, and you treat it with any type of anhydride and you get a product like this. Now see what happens, the lone pair of nitrogens are there, it can undergo resonance with this CO group and as well as with this ring. So that is why the lone pair of this nitrogen is now reduced. Okay, so the activity of this, the activation of this ring is also reduced. Now if you treat it with the nitric acid, you will get ortho position, you will get a product at the para position only, and then if you just treat it with OH minus and NH, then you will get back your NH2 back and there will be NO2 left. Now once this product is formed, the deactivated form, if you treat it with bromine CH3COH, then also you get only the parabromoaniline, and after that when you do OH minus and H, then, okay, just a minute. So when you treat it with OH minus and H plus, so what will happen, this particular Br group is converted, like this NHCOCH3 group is converted to NH2, okay, and you have the bromine at the para position. So this is all about the reactions of amines. Now we will see about something called as benzene diazonium chloride. This is such an important product, and using this we can prepare so many products. So that is why this is a separate thing that you need to study. So when you have this aniline and treat it with Na, NO2 and HCl, if it is an I can say aniline, and then you treat it with 273 and 278 Kelvin, then you get benzene diazonium chloride. Okay, now benzene diazonium chloride has a colorless crystal solid and it is also soluble in water. Now we'll talk about the chemical properties here. So here we have some reactions of benzene diazonium chloride which involves the replacement of this N2 group, and we'll talk about coupling reaction. So in the replacement of N2 group, we have reaction or replacement by Cl minus and Cn minus, replacement by I minus, F minus, replacement by HOH, okay, and replacement by NO2 group. So first let us see the first reaction, that is if you have benzene diazonium chloride and you want to replace it with Cl or Cn minus. So this is our Sandmeyer reaction, okay, where you can treat it with the salts of copper, salts of bromine and salts of Cn to get Cl, Br and Cl. Now there is also one more reaction, Gattermann-Koch reaction. Sorry, Gattermann reaction. Here, if you just treat it with copper powder and HCl, you will get chlorobenzene. Copper powder and HBr, you will get bromobenzene. And if you treat it with Ki, you will get iodobenzene. Okay, so this is all about, you can see, replacement with Cl minus and replacement with I minus. Now coming to replacement with F minus, first of all you treat it with HbF4, this is plus and this is minus. Now N2 plus is there, BF4 minus will there, this product will form. After that, if you heat it, then what will happen, N2 will go and fluorine will be added here. So ARF plus N2 plus BF3 will be the product here. Next, we'll talk about replacement by OH group. So if you treat it with H3PO2, okay, and H2O, okay, that is phosphor compound in H2O, then you will get simply benzene. You can get simply benzene from here by also treating it with ethyl alcohol. Okay, now if you will treat it with water, then what you will get? You will get phenol. Okay, so what are the reagents we can for Cl or Cn minus? You have Gattermann reaction and Sandmeyer reaction. For I minus, you have Ki. For F minus, you have HbF4. For H, you can treat it with H3PO2 or ethyl alcohol. For OH minus, or by replacement for OH, you can simply use as water here. Then if you want NO2 group, first of all you treat it with HbF4, plus minus is there. Here also N2 plus BF4 minus will form. After that, treat it with sodium nitrite and copper powder, and that will give you nitrobenzene. Okay. So next we'll talk about the coupling reactions here. So the coupling reactions is N2 plus Cl minus. If you take and treat it with phenol, what will happen? These two will react. HCl will be removed from here and you get a coupled product like this, and this is called as para-hydroxyazobenzene. Now if you take N2 plus Cl minus with aniline and if you react with HCl, then this is removed and you get a compound like this, para-aminoazobenzene, that is your yellow dye. Okay, this is your orange dye. Clear? Next is okay, next question. Okay, next is from the uses point of view. From here, a lot of time MCQs have been asked. So adrenaline, which is a I can say hormone present in our body, which contains a secondary amino group used to control the blood pressure. Ephedrine is also containing secondary amino group and it is used to increase the blood pressure. Novacin is a particular synthetic amino compound which is used in the anesthetic industry. Benadryl is also containing a tertiary amino group and this is used as an antihistaminic drug. Okay. So students, once again, I just want to tell you that very few days left for KCET exam. After your boards, immediately you have to start your preparation for KCET. So you need to have your test series ready before that. And I'll tell you, test series, writing test is one of the integral part to crack any entrance exam. So to help you with this, I have launched Fighter KCET test series, which you can avail at a very affordable price of just rupees 399. Okay, so you don't have to pay too much, but you will get the best quality here, designed by KCET experts based on KCET exam pattern, syllabus. There are total 18 full-length tests, 6 from physics, chemistry, maths each. Detailed solutions, you will get test analysis reports, and definitely for chemistry you will get the video solutions as well. So if you want to purchase this, the link is there in the description section. And yes, very few days are left, so please study hard, put all your efforts, how much ever you can put right now. Okay, and this is the time to work as hard as possible, and I hope you are enjoying the challenge. Do let me know in the comment section, have you started today's challenge or not? Thank you so much. All the best. Keep learning, keep working hard, and keep shining.